This is problem number 1 on the sample test problems for test number 2. Find dy dx for each of the following equations. A, y equals sine e to the 2x. This is a chain rule. We have sine of stuff. So to find the derivative of sine of stuff, we say, okay, the derivative of sine is cosine. Really important to copy that stuff once. You don't do anything first time you take the derivative of the outer function. But then the chain rule says you have to pay for it, and you pay for it by multiplying by the derivative of the inner function. So what we're going to do is multiply by the derivative of that stuff. So the derivative of e to the 2x, well, this is actually its own chain rule. The derivative of e to the stuff is e to the stuff again, but then times, and now we actually have to pay for the stuff that's up in the power. I'm going to multiply by the derivative of power. So this is the second chain rule, and the derivative of 2x is 2. Part B, y equals x cubed minus x over 2 minus x squared. This is a quotient rule. So the first thing I do when I'm doing quotient rule is I put the bottom squared so that I don't forget to do that. And now we apply the rest of the quotient rule. It says bottom times derivative of the top. So we copy the bottom times the derivative of the top. Derivative of the top is 3x squared minus 1. Minus in the quotient rule, not a plus, it's a minus. The top, copied, times the derivative of the bottom. Derivative of the bottom is just negative 2x. And it feels like stuff should be able to combine, so let's go ahead and simplify this a little bit. So we can FOIL in the beginning. And then we'll distribute over here. Don't forget, we got a couple of negative signs working, so I'll change that to a plus and this to a plus. Those two cancel. So now we'll just distribute here. So that's now a plus. And then we copy the bottom. Oh, look, I forgot to square the bottom, even if I said don't forget to square the bottom. Okay, so just a couple of things left to do here. First, recognize that you are not allowed to cancel these two things. And you're not even allowed to cancel the one on the top with one of these two down here because of that sign right there. Plus or minus, you cannot cancel. And you'll always have that opportunity when you do the quotient rule. And the other thing to say is that you never need to distribute on the bottom. You know, something is always being squared down here, so you have an opportunity to distribute. Don't. It's just going to make the thing bigger, and there's no hope of any terms combining or canceling. Whereas upstairs, it looks worse than it did before, but some of these terms will combine, so at least something positive will happen. So I'm going to grab the x to the fourth terms first. So that one, and we put them together, and it looks like we have a negative x to the fourth. And then I'll grab the x squared terms, that one, and that one. And I think that's a plus 4. Oh, almost missed one. You guys didn't miss one, but I missed one. So we combine those and we get, what is that, 5x squared? I think that's good. And then the last thing is the minus 2 upstairs. And I guess technically if you can factor the top, then maybe you should do that. I don't think this one factors, so I'm happy leaving it as it is. And we'll move on to part C. Okay, part C says find the derivative of y equals the square root of e to the square root of x, e to the 5x. Okay, this is a product rule. So we'll put our answer to part C down here. Y prime equals first times derivative of the second, and then the derivative of e to the 5x, that's a chain rule. It's e to the stuff times derivative of the stuff. That's the first part of the product rule. First times derivative of the second, and then the rest of the product rule says plus, and then we do second, just e to the 5x, times the derivative of the first. I'll do this off on the side here, but if you have the square root of x and you want to find its derivative, probably want to write it as x to a power. I'm actually just going to go ahead and write the final answer in here because to me it's worth memorizing what the derivative of the square root of x is because it pops up so often. So I will tell you that the answer, whoops, write this in another color, the answer is going to be 1 over 2 square root of x. It's just something I've memorized. The derivative of the square root of x is 1 over 2 square root of x. But if you haven't had it memorized, then we'll go here from the purple. So if I want to find the derivative of x to the 1/2, I bring the power down, copy the x, and then subtract 1 from the power. And then let's see if we can write that in a nicer way. So that's a 1/2, and then it's a negative power. So I guess that means it goes on the bottom and becomes positive down there. And then finally, that x to the 1/2 that we just wrote is actually the square root of x. So 1 over 2 square root of x is the derivative of the first. Not a whole lot of algebra we can do here. If you are so inclined, you can factor some stuff out of this. I guess we could factor out e to the 5x from both. That seems easy enough. And if you wanted to, you can combine the things in the parentheses and get a lowest common denominator, etc. I'm going to stop there. Let's move on to part D. So we want to take the derivative, or we want to find y prime. And this is ln of 3x plus 2 plus y cubed equals 12. So you are welcome to solve for y. In this case, it's not too hard to solve for y. I guess we'd subtract that ln from both sides and then take the cube root of both sides. But it's real easy for me to make up an equation where it's not possible to solve for y, no matter how brilliant you are. So I think the idea here is that if you see an equation with x's and y's all mixed up, and you want to find dy dx, that you're going to use implicit differentiation. So just kind of a different technique than the problems we did above. So what we'll do here is we'll take the derivative of both sides of the equation. So I'm going to write this. It's going to say the derivative of the left side is going to equal derivative of the right-hand side. Then we'll fill in the blanks here. So the right-hand side was just 12. Left-hand side, I'm going to copy it all. And again, the idea is that if you see x's and y's all mixed together in an equation, probably implicit differentiation is the technique. Okay, we'll start on the right-hand side. Derivative of 12, 0. Left-hand side, derivative of ln of stuff. That's chain rule. ln of stuff becomes 1 over the stuff times the derivative of the stuff. And the derivative of this stuff in here is just 3. Plus, now we're looking for the derivative of y cubed. So that's just 3y squared. Then we have to acknowledge that x and y are not equals in this equation. We're assuming that y is the dependent variable. And so when we take a derivative of both sides with respect to x, anytime you have a y term, the chain rule actually is going to come in and tell you to stick on dy dx. So anytime you take a derivative of some term with y in it, you have to pay for it with the chain rule multiplied by dy dx. Okay, there's no more calculus to do in this problem. There is some algebra because the goal, of course, is to solve for dy dx. So let's move all the other terms to the other side. So I will subtract all of this stuff from both sides, which will leave me a 3y squared dy dx equals, and then all that stuff is going to come over here and become negative. I'll go ahead and put the 3 upstairs. And then to solve for dy dx, we divide both sides by 3y squared. I'm going to write that as a multiply by 1 over 3y squared. So it's done, but we'll go ahead and cancel the 3's, and then I think it's really done. So our final answer, dy dx equals -1 over, and then we'll mush these two things together downstairs. No need to distribute, we'll just leave it like this. And it is quite common when you're doing implicit differentiation for the final answer to have not just x in it, which we're used to, but also to have y in it. So don't be frightened by that. It happens almost all the time we do implicit differentiation. Okay, so that was part D. Let's move on to part E. Y equals 5 arcsine of x squared. Again, it's a chain rule, so let's try this one here, E. So y prime equals, so the derivative of 5, well, it's a constant multiple, so it stays as a constant multiple. Arcsine of stuff. Arcsine is just its own special rule. The derivative of arcsine is 1 over the square root of 1 minus stuff squared. And the stuff in this case is what's in the parentheses. It's there in blue. It belongs right here in blue. No derivative yet. So it's just all part of the derivative of arcsine. That x squared goes there. Don't be confused by the two different x squareds. This is an x squared because that's what it was originally. This is squared because that's just part of the derivative rule for arcsine. The derivative rule for arcsine, 1 over square root of 1 minus stuff squared. It's part of the formula. But we're not quite done. Chain rule says, okay, now you gotta pay for the fact that highlighted in blue wasn't just x, but it's x squared. So you multiply by the derivative of that x squared, and we get 2x. So not a heck of a lot to do here to clean it up. We'll just mush everything upstairs and keep it on top. So 5 times 2x is 10x over square root of 1 minus, and then x squared squared is x to the 4th. And then finally part F, y equals tan of cosine of e to the x cubed minus 4. This is going to be a massive chain rule problem, so let's give it a shot. Part F, way down here. Okay, y prime equals, so we work outside to inside. Derivative of tangent of stuff is secant squared of that stuff. So the stuff is everything that's in there. It's cosine of e to the x cubed minus 4. Close the parentheses there. So currently we have dealt with the tangent. Tangent of stuff becomes secant squared of stuff times. Now we're doing the derivative of all this stuff. Derivative of cosine of stuff is negative sine of that stuff. And the stuff is now changing roles. We did cosine of this stuff, so that is what goes in these parentheses down here, e to the x cubed minus 4. So that was cosine of stuff. The derivative is negative sine of the stuff times the derivative of the stuff. So now we are worried about the derivative of what's up there in red. This whole thing right here, we need the derivative of that. And the derivative of e to the stuff is e to the stuff, so we copy, because that's the derivative rule for e. E to the stuff becomes e to the stuff times derivative of the stuff. And then finally, we'll highlight in blue here, we are at this stuff, which is the last stuff. So the derivative of that stuff is 3x squared. And I don't really see much algebra we can do here to clean that up. It's just kind of nasty. Maybe you could move the negative all the way to the front and move the 3x squared to the front. That's about all we can do.